Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hello all, welcome back to day 25 of 100 days to CAT Quant series. In this video, we will be discussing 5 questions from number systems. So whenever you come across a question on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. Or in case if you want to attempt these 5 questions as a test, you can log on to the gurukul.org.in. All you need to do is you need to sign up so that you'll get access to a course called 100 days to CAT, in which you'll find 100 tests on each of the 3 sections, right? So they are absolutely free, and if you are a serious aspirant of CAT 2025, make sure that you attempt these tests. Now coming to the first question, the product of some natural numbers all under 25 is 17, 30, 520. These numbers are arranged in ascending order, right? So we do not know how many numbers are there. The product of the first 3 of those numbers is 3420, right? So the product of these 3 is 3420, and the product of last 3 of those numbers is 9614. What is the product of the first 4 of these numbers? So we already know the product of the first 3. So we are asked to find the product of first 4 of these numbers. So we need to find the fourth number, right? So if we can somehow manage to find a fourth number, 3420 into that will give us the answer, right? Now the product of last 3 numbers is 9614. Now first let me divide 1730 by 3420, right? So that should be 1730520 should be equal to 3420 into 506. Now if I assume that there are 3 more numbers, the product of these 3 has to be 506, but it is given that the product is 9614. So that tells me that you do not have 3 numbers. That should be less than 3, right? And you cannot have a single number because all the numbers are under 25. So I can conclude that there are only 2 numbers, right? So 1730 was written as a product of 5 numbers only, and the product of the last 3 numbers is given to be 9614, right? So the product of these 2 is 506. Now if this is 506, what is this number? 9614 by 506, which is 19. This is not required, right? Now our job is to write 506 as a product of 2 numbers such that they're both under 25. Now how can I write 506 as product of 2 numbers such that they are under 25? Both the numbers should be under 25. So that is 22 into 23, right? So we have 19, this should be 22, this should be 23, right? Now what was asked? Find the product of the first 4 of these numbers. Now this is 22. So we know the fourth number 22. So 3420 into 22 should be the answer for this question. Now coming to the second question. Find the number of composite factors of 4320. Right. Now first let me write this as 10 into 432. 10 I can write this as 2 into 5. 432 I can write this as 4 into 108. 108 can also be written as 12 into 9. So this would be 2 into 5 into 2 square into 2 square into 3 into 3 square. So this would be 2 power 5 into 3 power 3 into 5 power 1. Now first let's find the total number of factors. The total number of factors would be 6 into 4 into 2. That is nothing but 48. So you have total of 48 factors for 4320, out of which 2, 3 and 5. You have 3 prime factors. So 48 minus 3, 45. And you have a factor 1. Right, 1 is neither prime nor composite. So 45 minus 1, 44 should be the answer for this question. Now coming to the third question. What is the remainder when 1011943 power 14 when divided by 7? Now first let's find the remainder when 1011943 when divided by 7. So 7 ones, 4's 28, again 4's 28, 39, 5's 35, 44, 2. Right. So I can write this as 2 power 14 by 7. Right. Now I will write 2 power 14 as 2 cube whole power 4 into 2 square by 7. Now 2 cube is 8, 8 divided by 7, the remainder is 1. So 1 power 4, 1, right? Whereas into 2 square, so you are left with 4 by 7. So the remainder when 1011943 power 14 divided by 7 is 4. Now coming to the fourth question, how many two-digit numbers in base 4 are two-digit numbers with the same digits but not necessarily in the same order in base 10? Now for example, if I consider a number AB in base 4, now can that be AB in base 10? No, right? Because here you have base 4 and base 10, right? So given that they should be having the same digits but not necessarily in the same order, so this should be BA in base 10. Right. Now let's convert this to base 10. So AB in base 4 will be same as 4A plus B in base 10, which is equal to 10B plus A. Then what do we have? Bringing A to left hand side and B to right hand side. So 3A is equal to 10B minus B, 9B, or A by B is equal to 3 by 1. So what do we have? If the value of A is 3, the value of B is 1. If the value of A is let's say 6, the value of B is 2. If the value of A is 9, the value of B is 3. But we have this number to base 4 in base 4, right? So none of these two, A or B, cannot be greater than or equal to 4. So you should not be considering these two cases. So you have only one number. That means 31 to base 4 is equal to 13 in base 10. So the answer for this question should be 1. Now coming to the last question, find the number of zeros at the end of 855 factorial whole square. Now first let's find the total number of zeros in 855 factorial. Now for that you need to first divide this by 5. So what is 855 by 5? 171. Right, again dividing 171 by 5, that would be 34. Dividing 34 by 5, 6. Dividing 6 by 5, 1. So 171 plus 1, 172 plus 34, 206 plus 6, 212. So you have 212 zeros at the end of 855 factorial, but we are asked to find the number of zeros at the end of 855 factorial whole square. So there will be double this number. So 424 should be the answer for this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.